Math 116, section 0.7, perform the operations and simplify. Simplify. Simplify might be a word for you're in for a lot of math. So question number 17, we have y squared minus 2y plus 1 all, that goes on, times divided by 7y squared minus 7y divided by y squared minus 4y plus 3 all divided by 35y squared. I'm going to pause and make sure I wrote that correctly. We can keep going. So the first thing to notice is this divided by, we want to make that a times so we can start canceling things. So the first thing you want to do is change this to a multiplied. So it's y squared minus 2y plus 1 divided by 7y squared minus 7y times, and I'm going to flip it. So when I change it from divided by to multiply, you flip everybody. So that one goes to the top, numerator goes to the top, y squared minus 4y plus 3. So all I've done is sort of flip the directions of these guys. So now I'm going to start factoring. And I want to factor so that I can cancel things out. This will make my life easier. So factoring here, well, 35y squared, that doesn't factor. But this one down here, 7y squared, that can factor to 7. I'm going to pull out a y from each one, y. So that gives me a y, right, because there's a 7y squared, so it leaves a y, minus 1. Okay, 7y minus 1 on the bottom. Up here, we're going to do our FOIL method bit. So this is y. I have a plus, so that means they're either both plus or both minus. But that one's minus, so they must be both minus. Y minus 1 and y minus 1. These are factoring. Okay, over here that stays the same. That's just 35y squared. Can't really factor that very much. And on the bottom, I'm going to factor this one with our reverse FOIL method. Again, this is positive and this is negative. That means both of these must be negative. And 3, so minus 3 and 1 gives us minus 4. Okay, so here is the big thing, and then we can start canceling. We have y minus 1 times y minus 1 all divided by 7y times y minus 1 times 35y squared, it's right there, divided by y minus 1 times y minus 3. So now we get to cancel. I actually really enjoy canceling. It's a little strange. To me, it feels like scratching stuff off a to-do list. And we can cancel because this is a multiplying. When it was dividing by, we couldn't cancel. You had to flip them first. So when it's multiplying, you're good to cancel. Y minus 1, y minus 1, okay? Oh, look, y minus 1. See, it's very satisfying. There's a y there, and there's a y there, but that leaves us with a y. So if you have anything left over, I like to write it, otherwise I forget about it. 7, 35, that leaves a 5. Okay, so now this whole thing equals 5y divided by y minus 3. Well, I will agree with them that that is simpler. Okay, I'm going to do another one. Question number 31. So, question number 31 is x divided by x squared minus 4 plus 4 divided by x squared minus x minus 2 minus x minus 2 divided by x squared plus 3x plus 2. So we can't cancel. I can't just go, oh, cancel, 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 because these are plus and minus, so you can only cancel when it's a multiplied. So the first thing I want to do is get everything on the same line so I can cancel, because I like to cancel. Okay, so what I notice, I'm going to factor first so that I can find the common denominator so I can add all these, is x squared minus 4, that's x plus 2 times x minus 2. I'm factoring so that I can look for a common denominator. X squared minus x minus 2, that's x minus 2 and x plus 1, because the FOIL method will give me x squared plus x minus x, that's minus x minus 2, like that. This one's a long problem. Again, reverse FOIL method, we have x plus 2 and x plus 1. So that gives us our plus 3 in the middle and then plus 2 in the end. Okay, why did I do that? Because now I'm seeing some commonalities. I see x minus 2 and an x plus 1. So if everybody had an x plus 2, an x minus 2, and an x plus 1, we could put them all together. So here's what we do. We think, well, this piece is missing an x plus 1. So I multiply this by x plus 1 over x plus 1. This piece is missing an x plus 2. I'm looking for the lowest common denominator. What you do to the top, you do to the bottom. That doesn't change it because that's the 1. And this piece has x plus 2 and x plus 1, but it's missing x minus 2. X minus 2. So I'm multiplying. So on the bottom, our denominator is going to be equal to x plus 2 times x minus 2 times x plus 1. This is the denominator. But to save space, I'm denominator. I'm just going to leave this over here for the side and focus on the top. So this top piece, everything up here, turns into x times x plus 1 plus 4 times x plus 2 minus x minus 2 times x minus 2, like this, because you're subtracting this piece, all divided by denominator. I don't want to rewrite it every time. I need the space. So the denominator there, that's that thing. And then you can do this on your homework. You don't have to keep writing the same thing over and over if you're just gonna, that's denominator, right? Denominator, or bottom part. So this thing on top here becomes x squared plus x, I'm multiplying this out, x squared plus x plus 4x plus 8, right? 4x plus 8 minus, gotta multiply this piece together first. That's x squared minus 2 minus 2 minus 4x plus 4, right, this guy. So we say minus, it'll be minus x, oops, I want white, minus x squared, and it's minus, so plus 4x minus 4, all divided by denominator, equals, canceling, x squared plus x squared minus x squared, they cancel. So we have x, I'm counting my x's. I got a 4, 8, 9, so that's 9x. So plus 8 minus 4 is plus 4. 9x plus 4, all divided by, well, now I'm at the end of the problem, so I have to write the denominator again. Ideally, you would have put it like over this way and you put the denominator on the bottom, but I didn't have space. So divided by, and it is x plus 2 times x minus 2 times x plus 1. And that is your answer. This divided by. Ta-da! So mathy. You let your little creative mind just kind of play with the numbers.